So this is Chemistry 2.1, Nature of Substances and Chemical Reactions. This question comes up quite often. All you've got to do is work out the charges of each of the ions. So in this case, it's a plus and a negative, and then you work out the formula of the compound. Okay. The next one, then you've got one positive to two negatives. So obviously you've got to add an extra positive. So it would be Li2, SO4. The next one then, so you've got 2 plus to 1 negative. So again, you've got to add 2 of the negative. And then finally, again, you've got 2 plus to 1 negative. You've got to add 2 of the negatives. All of these common ions are found at the back of the paper. Moving on then to a similar type of question, complete the table. These questions are commonly left out because there isn't an actual line. So you've got to work out what the compound would be called. So if you added copper to oxygen, what would you form? Copper oxide, and that would be the chemical formula. The other one then, so calcium chloride, what two elements make that? Calcium and chlorine. And then magnesium bromide, again, turn to the back of your paper. Magnesium is 2 plus, bromine is 1 minus, so you have to have 2 of the minus to make it overall neutral. And then the two compounds, elements that go into that are magnesium and bromine. Moving on then, space filler diagram. So they've given you a space filler diagram there. They've also given you, help you then to complete the key. So if it's CO2, you know that the dark black one is just the carbon because there's only one carbon in that compound. And you've got 2 oxygens, so the oxygens would be the ones that are white or not filled in. Moving down then towards the bottom, you had to then use the key to fill in and draw the diagrams. Okay, remember what I said before, lone element in the middle. So in this case, the oxygen is the lone element. So oxygen goes in the middle and it's surrounded by 2 hydrogens. You get the information from the key at the top there. The second one then, 1 carbon, 4 chlorines. So put the carbon in the middle and then the chlorines again on the outside, and you get the chlorine and the carbon from your key at the top. Moving on then to some harder questions, okay? Use the equation to calculate the maximum mass of copper that can be produced when using 1.5 tonnes of carbon. So the first thing I work out is the number of moles in carbon, and that's mass divided by AR or MR depending on whether you've got an element or a compound. So the mass they gave you was 1.5 tonnes. The AR there is 12, so you've got 0.25 moles of carbons. Then looking at the equations, you're trying to work out how much copper is produced when you react the carbon. So you've got 1 mole to 2 moles because it's got 2 in front there. So times it by 2. So the moles of copper would be 0.25. Then what you've got to do to work out the mass, just rearrange the moles equation from the beginning. So you've got AR times the moles. The AR there, copper is 64. You've obviously got 2 coppers, so you've got to times it by 2. Then times it by the number of moles, and that works out the mass. Nice 3-mark question. Remember to follow the steps. So work out the moles first, then the ratio, then the mass. Work it down in steps. Then says, when the reaction was carried out using 1.5 tonnes of carbon, it was found that the yield was only 12. So this is a nice little then extra question working out percentage yield. So actual yield divided by theoretical yield. So you worked out theoretical yield before, so it's 32. Even if you didn't get the answer for that right, you'd still get the mark if you did the correct equation here. It's called error carried forward. So 32 is the theoretical, 12 is what you actually got. Divide them by each other, times by 100. So percentage yield is 37.5. Another question, again, quite similar, working out the elements and the formulas. So calcium hydroxide, what elements is in there? You can see calcium, oxygen and hydrogen. Just write them like that. The next one then, sodium carbonate. Carbonate is 2 minus and sodium is 1 plus. You've got to put 2 sodiums in to make it balanced. And then the next one then, calcium is 2 plus, nitrate is 1 minus. You've got to put 2 of the nitrate in to make it balanced. Remember, you're always trying to get to 0 with these. Don't have to remember them. They are in the back next to the periodic table, the ions. This question comes up quite often. Sodium oxalate naturally occurs in many plants. It can be made from oxalate acid. Oxalate acid contains 2 hydrogens, 2 carbons and 4 oxygens. Use this to give the formula of oxalate acid. Okay, it doesn't matter what order you put them in. So you've got 2 hydrogens, 2 carbons and 4 oxygens. Question number 6 then is essentially exactly the same as question number 4. Like I said again, the same step. So this time you're trying to calculate the mass of copper when 2.5 tons of copper sulfite react with excess oxygen. So exactly the same thing. You know you know the mass of copper sulfide, so work out the number of moles. So they give you essentially the ARs of copper and sulfide, so you've just got to work it out. So mass divided by MR, that's working out 2 coppers and 1 sulfur. That equals 0.128. Like I've written here, keep to 3 significant figures until right at the end. Okay, so keep it quite a high number of significant figures until the end. Exactly the same second step, work out the ratio. So you've got 1 copper sulfate to 2 coppers. So again, the moles of copper will be timesing that by 2. Again, I've kept it in significant figures. Then finally, exactly like we did in question number 3, work out the mass now. Okay, so you've got the moles times the AR, which you carried forward there. So you've got, sorry, I should have written that there as well. And that's 3.32.8. Next thing then says calculate percentage impurity. That's exactly the same as calculating percentage yield. They just use a different word to confuse you. So I've done exactly the same. Theoretical divided by actual times by 100. So that works out the percentage of copper. And then I've then worked out how much of it is impure. So 1 mark for working out how much is copper, then 1 mark for working out the percentage of it is impure. If that much is copper, the rest of it then's got to be something that is impure. I do believe, yeah. Finally then, a chromatography question. These questions come up quite often. So it says, give the letter of the horse A to D that was given paracetamol. So you want to find out the paracetamol. I've highlighted there. Paracetamol is the dot at 3 centimetres. So you're looking then for a horse that's also got a dot at 3 centimetres, and that is horse with the letter C. State given a reason if any of the 4 horses were given caffeine. So caffeine has got a dot at about, what's that, 7.5, so 7.4, 7.5. Can you see how I've drawn it just to make sure, made a mess of the paper? That's fine. And you can see that none of the horses have also got a dot where the caffeine is. So no horses were given caffeine, as there was no caffeine in any of the horses, and you can see that there. Then the final question says, calculate the RF value used to identify substance using the following equation to calculate the RF value of paracetamol. So how far did the solvent move from the start to the finish? That's 10. How far did the paracetamol move? That's 3. So 3 divided by 10 equals 0.3.